Hey everybody, it's Nick. For today's tutorial, I got the last part of the digital fabrication project with the catenary vault. We're going to go ahead and make our pieces ready for laser cutting, and we're going to try to optimize or save some material while we're at it. And so, if you start from the last set of scripts we had, we got to the point where we've got the curves, ready to bake. We got the outer curves, the tabs or the fasteners, and then the cuts for the openings, and then the numbers. And what we got to look at is, right now it says to bake these, and if we did bake them, that's how we're going to get the curves out that we can export to a laser cut template. But as you can see, like we got a lot of like wasted material. If this was one big sheet, it's not really ready for the laser. We also have a lot of extra parts. If you remember, like when we made our sheet, we looked at the UV coordinates. We tried to get pretty close, but I've got a lot of extra part number 57s, and I could cut those out and throw them away or whatever, but that's also pretty wasteful, and so I wanna try to avoid that if I can. So those are the things we're going to be trying to address today. So again, you could bake these. And then you could arrange them yourself, onto a sheet. But that might take a little while, and you probably don't have time for that. So what we're going to talk about today is a technique called nesting. And in order to, and basically like nesting means arranging parts to save material. And the plugin we're going to be using for that is called OpenNest, and it's got a lot of nice components that can help us basically like arrange objects. And so the first thing we want to do is I'm going to go ahead and the way that Rhino Nest works is a little odd. And so we're just going to start by working with the outer with the outside with the outside curves, and the base that we have for these things. We've got 57 actual pieces. Sorry, 58. But the output is going to be 64. We have an 8 by 8 grid. And so what we're going to want to do is like reduce that tree. And there's no really good way to just cut out parts of a tree the way that you would remove points. And so the way that I do it, and somebody could probably tell me a better way to do it, but is to use a split tree. And the split tree will take the tree as input. And then we have to do a like a mask, which is basically just a filter. And the way the filter works is you look at the structure. It's 0, colon 0, colon 0, up to 63. Well, we want from 0 to 58. So I'm just going to do 0, and I do like curly brackets first. Curly brackets, oops, come on. Curly bracket, 0, colon, 0, colon, 0 to 57. Close brackets. And if I plug that in, now my list is 0 to 0 to 57. And that's basically what we've got. There's just a little bit different in terms of the way, whether it's simplified or not. And so you can see, there you go. Got rid of those. Got rid of those duplicates. That's excellent. That's what I want. Okay. And then I'm going to go ahead and drop the open nest component. And this is a big one. There's a lot of settings on here. I'm not necessarily going to go through them all, but what we're going to want is to go ahead and pipe in this geometry into here. And we're going to keep that data structure the way that it is for now, because otherwise we're going to lose the groups of things, and that's not good. And then for sheets, what we're going to do is we're going to draw a rectangle, and it's going to look at, if you look at our template here, we're going to pay attention to what the sizes are, whether we're cutting basswood or whether we're going to cut like acrylic. And this says 24 by 18, so that's what I'm going to go ahead and use. Use whatever the like correct template is for the laser cutter. But anyway, go ahead. I'm going to make a rectangle from the corner 0, 0. The other corner is going to be 24 inches. I believe ours is actually 16 inches now, but you should verify that. Okay, so 24 by 18. Okay, so we got that as our curve, and I'm going to set a curve component. That's going to go to sheets, and I'm going to set this thing. All right, and let's see what it's not happy about. Okay, so let's see here. Oh, I think it wants curves. Okay, so For this one, I'm just going to go ahead and join. I'm going to join these and then flatten them and plug it in. Ah, there we go. Okay. So I'm going to hide all this stuff now. And I'm going to go back and hide these. Okay, so this is what it ended up giving us. And if you put in a sheet, here, it's actually going to give you like as many sheets as it thinks, it needs. And there's still a lot of wasted space here. I'm going to go ahead and hide this too. So the trick is to change the spacing component, and the documentation recommends. Let me move this over here. The documentation recommends 0.001. If that gets in your way, you can go ahead and increase it. But the smaller that number, the closer the parts are going to fit together. So you go ahead and run that. And whew, there you go. You got them all to fit there. So that's pretty good. All right. So we got all those parts to fit on the sheet. Now, if you didn't like that, you can do a couple different things here. You can if you do a Boolean toggle, you can reset the thing. Try to run it again. It's probably as optimized as it's going to be. The other thing you do is if you put a seed, put a number slider in, just like a random number, you can control the seed, and it'll kind of shift the pieces around a little bit to show you some different orientations. Okay. So you can kind of play with that. The other thing that you can do if it's too close to the edge of the piece, you can drop like a spacing component. I'm gonna make sure this isn't running right now, and you can increase the spacing of the parts. Yeah, and it'll give you a little bit more spacing. Just make sure you turn off run because it's gonna keep trying to find a better solution. That's pretty nice right there. So anyway, you can do that. So that's what that gives you. Then you can kind of experiment with that. But okay, so we got our sheets that's referenced. That's our material. We've got our the spacing value. Everything's run. Okay, so the reason you say, well, Nick, why can't I run everything at the same time? Just because of the way this thing works and the way the data structure is, I would run the outer polygons first. What that's going to give us is the transformation value, which is basically a way that the computer will say, okay, take these objects that we've got here and rotate them and move them and place them like here. And then since we figured out what that is for the largest piece, we can then use that for all of the other pieces. And that's what we're going to do. So what I'm going to do is just do a transform component. And I'm going to plug in the transform here. And the transform starts at 58 transforms. I'm going to graph that because everything else we've got is grouped, is already in a tree structure. And what I'm going to do is I'm going to go ahead and I'm going to copy this structure here and plug in this branch here. And you can see that's, if you look at it, that's where things are going to go. That's great, and I'm actually going to go ahead and put a geometry component here. So we get that. And then I'm going to go ahead and hide this now. Okay, so now we got that. And I'm just going to turn this back on. Okay, so now we've got our outside edge for the template, our geometry from the first round, and then if we take the second batch here, so this is already, if you look at this, it's 0063, just like the first one was. We're going to plug it in, and there you go. So now things are going to go where they're supposed to. Okay. And actually, you could probably keep this the way it is. It doesn't change. But I'm going to copy, paste this group again. I'm going to move this aside because this is where all the good stuff is. And I'm going to go ahead and plug in the next round into D here. There you go. And you can kind of see where this is going. So we're going to copy this again, plug this one in. Now I got our openings. And then one last batch here. We're going to take these numbers and plug them in. And that's pretty good. And now I think it's all parametric. So if I went back and actually changed the spacing, oops, not that big. Yeah, it's actually going to put them all back. So that keeps the parametric relationship pretty much solid there. So now, instead of, oops, what I had, which was, I said, bake these. That's not really quite true anymore. These are the parts we nest. There we go. And copy paste that. These are the parts that we're going to bake. Don't bail them. Bake them. There we go. Okay. And that's pretty good. And what you could do to make things easier, I would go ahead and group these together. Bake doesn't really work too well if you just select things with shift. It really works well in this fashion. So you've got all these. I would go into Grasshopper, or sorry, go into Rhino this time. And we have your default file. I would say that this is like the default layer is probably like the cut sheet, edge. If you go into our Iowa State template, and this is different for everybody, for every school or whatever, the template I have, which I think is current, says that red is for vector lines that'll be cut, and yellow is for lines that'll be engraved. And so we want to cut pretty much everything, and then we want to use yellow to like edge the numbers. And so that's what I'm going to do. I'm going to go ahead. I got like a red layer. That's probably fine. And then for here, you can't really use yellow because it's the color that things are selected in Rhino. So I would go with kind of a mustard or something just to have a difference. And you can make it whatever you want as long as you keep them straight. And then I would go ahead. So I've got these here. And oh, yeah, rename this. Let's see, rename to cut. I can't. There we go. And let's see. Then we're gonna call this one score. Okay, so go back to here. So first thing you do is probably put the cut sheet edge on here. So I'm gonna go and bake that to. Oh, I said I can't spell sheet apparently. Cut sheet. Okay, we're gonna go ahead and bake that to cut sheet edge. Make sure that's there. Yep. And then we're going to go here to the group and we're going to bake it to the cut layer. And I would go ahead and group them just to make it easier to move around. So we'll go cut, verify that. Yeah, there we go. Awesome. Good. And then the last one is going to be baked to the score layer. Score. Okay. And so from there, you can go ahead and let's see, if that's everything, I would go ahead and select it, and then say export selected, and then go ahead and save that as, I think you can save it as Adobe Illustrator. Say my cut sheet, and let's see here. Let's say preserve model scale, and say OK, and open it up. So here's our, oh, except I saved it, yeah, except the view, I saved it as of the view. That's not good. Okay, hang on a second here. Let's go back. Okay. That's strange that it did that. Let's see. Make sure that preserve scale. Huh. Okay. Let's see here. Go top view, say export selected. Preserve scale. Okay. Save it. Let's go ahead and open it up. Okay. So I'm gonna go ahead and select everything. Control A, Control X to cut. Go to my sheet. These are all locked, so that's good. And then paste. And those dimensions look a little big. 24 by 18. Yeah. So, and that's how we put them on there. I don't know. Huh. Oh, so I figured out what the problem was. This says 24 by 18, but I don't think that's quite right. I actually do think it's actually 24 by 16. And so, but that's easy to fix. So we just go ahead and make a box that's 24 by 16. You can see that. And then I'm going to set that for the sheet. And yeah, so there you go. So we've got that set now. And I am going to go ahead and delete all those other parts here. Um, Hang on, I just invert this. That's the beauty of parametrics, folks. It's real easy to change things, if you have something messed up. It also reminds me of something though. Before you export it, I would go in and clean this up. And what I mean is like once it's baked, if you've got things that are really close together, go ahead and shrink that. If these for some reason I don't know what's wrong with this piece. I think the plane got flipped. If that's going to be if this piece is going to get too close, you go ahead and take care of it. If you've got parts in the model, like if I'm looking at the actual model, sorry, I'm going to take a step back here. If I've got parts in the model that are, let's go all the way back here. Yeah, I guess this is it. Um, where you can tell that you don't need this one cut. You don't need this cut out. You don't need this outer edge, right? Go ahead and get rid of those on the cut sheet. Like use the reference model, follow the numbers, just have somebody in your group go in and clean this thing up. Digital fabrication, with like computation, it's not super intelligent. Like there's still little things that you'd like to fix, little craft pieces. Before you laser cut, that's the time to do it. So go ahead and go back through that model, go and turn that stuff back on, and clean that thing up before you get too far. All right, and so yeah, so that's a good pause for everybody. Let me go back and delete. Yeah, just go ahead, undo that operation there. So that kind of bugs me. Okay, so I'm sure you guys all caught that before I did. So I got my parts. Let's go back and do it again. So I'm gonna go ahead and bake the sheet to the cut sheet edge, and then go ahead and bake this group to the cut layer, and then go ahead and bake the score layer for the numbers. Okay, and then if I go to top view, select all, Control A, and then I say export selected, just keep it back on my cut sheet, model scale, RGB, okay, go back to Illustrator, go to open up the cut sheet, hopefully it messed something up there. Let's see here. There we go. Okay, it's back. Whew. Okay, zoom out. Control A, select all. Control C, copy. Control V, paste. Okay, move this over here. And if you've got that outer boundary, still not quite. I don't know. I guess that must just be the dimensions of the sheet. So you guys, please pay attention to that. But basically, thank goodness I've got nesting, so I can pretty much fit those parts on there without too much trouble. So it fits within that box that we've got from the output center. It looks like I've got a little bit of room on the bottom too. So just kind of center it. And then when you're ready, go and delete the outer box. You've got these, and it looks like let's see, yeah. So if you've got problems with the, yeah, okay. So they don't have the layers anymore, but what I can do is I can select by color. So I can just choose this and then say select, same, let's see here, stroke color. And then it says all red layers must be 0.01 points. Okay, so I can go into stroke here and I can go 0.01. And then I can go into and I can choose one of these numbers. And I can go to select, same stroke color again. And let's see, yellow must be 0.01 points. Okay, fine, 0.01. And assuming, you got everything. Oh, and actually assign global yellow. So, ooh, I got to go back and do that. So, select same stroke color, and I've got to go with my swatches. What happened to my, let's see, window swatches and assign global yellow. I got in trouble there. And then go back to my things here and say select same stroke color, global red. Now we're cooking with lasers. All right. Ooh, can't really see the yellow. All right. I trust that that's gonna work. Again, you guys have a lot more experience cutting stuff on the laser, but that is a template file. That is something you can cut on our laser. And it's nested. Oh, one thing, yeah, get rid of that outside thing there. Oof. Um, Before you get this far though, clean it up. I see a lot of stuff that is not going to quite work. You might even get rid of that entirely. That's not very much fun. Um, yeah, there's always little glitches and things. This is a example of the computational strategy. Um, you know, um, with the way that you handle like when you have like an exception. You want to handle exceptions last. So make all the things that are mostly right. Make all those changes, make all those parts, and then just fix the couple of parts that aren't quite right. That's a way better use of your time. It's way easier to fix here than it is to go into the script and try to find that one piece and try to fix it so that everything is right. Um, Sometimes that's what you have to do, but a lot of the times it's not. Like something that's good enough is just fine. You can fix it easier in Rhino than you can fix it in like Grasshopper, and that's often true. So that's it. That's a round trip through the whole thing. We went from a catenary surface all the way to the parts, all the way to the parts that we're gonna use to fabricate it. So that's pretty awesome. So give yourself a pat on the back and get to the laser cutter and start fabricating. And while you're at it, keep this model open with your dots, and that's your reference. Okay, it's gonna help you like divide work, to check your work, and make sure that you've got the right piece. You really want to have a process that's very careful so you can avoid mistakes. Fortunately, with zip ties, they can be pretty easy to undo. If you glue things together, that's not always the best. Zip tie, you can just cut it and retighten it if you have to, and that's not too bad. Remember, you've got to come up with some kind of bracing for the bottom. I'm going to leave that to you guys to design. And you've got to have a heavy base. If you don't have a good base and good bracing, this thing's it's going to want to push out. Okay. And to design that, I'll leave it up to you. You could design it, after you build it, and then kind of come up with some kind of brace. You could go into Rhino and use this angle and then actually laser cut like a brace. You guys are very smart. I think you can figure it out. So anyway, that's the last kind of step in how you fabricate it. I will give you a cleaned up version of this script that you can run. Remember, this will be different for yours. You've got to figure out like what your geometry looks like, what those base numbers are. Hopefully you don't have more pieces than I do. This is already a lot of pieces. You're talking about 58 pieces. Lot of zip ties. We talked about that too. So give that a shot. Good luck with lasering. Good luck with fabricating. We'll see you in class.